Whoa, I can't believe that worked. Hi everyone, it's Mr. Isaac. Welcome to another edition of Physics Underground. In this episode, we're going to look at the physics of projectile motion, so let's get to it. Hi friends, this is Mr. Zarzak, and in this video I'm going to demonstrate the ballistics cart. Okay, it's called the ballistics cart because it's just a cart on wheels, so it rolls. It's called ballistics because it shoots. Alright, so on top there's a little vertically mounted cannon. Okay, and then the way that you release it is you just pull this little string, okay, and it shoots a ball straight up into the air. Alright? The idea is, or the question is, well, what would happen if we took and we triggered the cannon while the ball would roll? Okay, and so that's the demonstration. So let's just go ahead and do it. Okay, so reset the cart. Okay, so we'll set it into motion. Here we go. 1, 2, 3. And look at that. It goes right into the hole. Now the question is well, why? All right, so let's talk about it. Okay, so to help us understand why, it's really a matter of thinking in terms of components. All right, this is all about vectors. All right, when you take something and you throw it up in the air, the reason that it comes back down at all is gravity. Okay, one thing that we've learned about gravity is that, well, number one, it only points downward. So like if I take and I just let the ball go, okay, or if I let two balls go, okay, well, they're only ever going to just fall down if I release them. They're never going to fall sideways or up, okay, or forwards or backwards if I just let them go. Okay, so that's the first piece, is gravity points straight down. Okay, and when it comes to straight down is exactly 0 left and right. All right, and the rules of components just say that if two vector components are perpendicular to one another or at right angles, they're independent. In other words, there's exactly 0 left and right or forwards and backwards if it's just up or down. In terms of motion, all right, well, that just means that any motion in the vertical plane has 0 effect on the motion in the horizontal plane. Okay, there's no gravity sideways. All right, so the point is that if something is moving sideways, okay, it's going to maintain a constant rate of motion. So like if I take if I have two of these little ball bearings, and I let them go on top of this ramp, watch them roll along the table. Okay, they just move along at the same speed, and over this shorter distance, there's just not enough friction on the table to really slow them down much, so they can maintain a constant velocity. Okay, well, such is true when I take something and I shoot it up in the air. If I'm moving sideways with it, okay, well, that sideways motion is unaffected by gravitation. The only thing that affects it is any air resistance, and over this short distance, air resistance doesn't do anything. All right, it's not going to slow us down or speed us up enough to make a difference. So like, if I take a ball and I throw it up in the air, okay, well, I know it's just going to come straight down to me. All right, if I take and I walk along sideways with the ball and I throw it straight up in the air, as long as I maintain a constant rate, the ball's just going to come right back down in my hand. Okay, one thing that you can try on your own is have someone drive a car, sit in the back seat, stay on a straight road, tell them to maintain speed, and you just play catch in the back seat just like this. Okay, and you don't have to throw the ball forward or backwards. Okay, as long as you're moving at a constant rate, that sideways motion is going to remain constant for the ball, just like it did for the two balls rolling down the table. All right, so if I go and I do this again, if I just kind of throw it in the air, if I don't think about it too hard, it's like I don't even really have to look. As long as I just kind of maintain a constant rate, the ball is just going to come right down into my hand. Now, if I'm walking along and I throw it up in the air and I stop, you can actually see the ball continue to move forward. So again, if I'm walking along and I throw the ball up and I stop, the ball continues to move forward. Or, counter to that, okay, if I take it and I'm walking along and I accelerate, I'm going to run into the ball because the ball is just maintaining a constant rate this way. Okay, and so that's the idea, is you've got this independence of horizontal and vertical. Vertical, you've got gravity acting to slow it down and then speed it up, but that only acts this direction. Sideways, we maintain constant speed.